AWS Storage Best Practices for Cost Optimization. My name is Matt Sidley, and I'm a product manager with AWS Storage. And I'm joined by my co-presenter, Arushi Garg, also a product manager for AWS Storage. Today's session will cover how customers are migrating from on-premises to the cloud and unlocking immediate cost benefits. And then once they're there, how you can leverage the different AWS native services to further reduce costs and use our tools such as monitoring and automation to reduce your cost of storage. By the end of this presentation, you'll be equipped with actionable strategies to right-size your storage and to continuously monitor and improve efficiency using AWS services. So let's look at what we'll cover today. First, we're going to talk about the cost optimization for moving to the cloud from on-premises and unlocking those cost benefits. Second, we're going to talk about choosing the right storage for your workload. AWS offers a variety of purpose-built storage options: Amazon S3, EBS, FSx, and EFS. And each of them are designed for specific use cases, so we'll talk about which use cases are a good fit for which service. And third, once you've selected the service for your workload, you can use AWS tools to continuously measure, monitor, and refine your infrastructure to provide the best storage efficiency. We'll show you how to use each tool for each service and how you can save up to 80% on your storage costs by using these native tools. We'll also share real-world examples of customers who use these tools to further reduce their storage costs. All right. Let's first talk about managing on-premise storage, and it often means dealing with over-provisioning and inefficiencies. So let me walk you through a typical example. Imagine that you need to store 400 terabytes. However, for future growth, you buy ahead. When I talk to customers, they usually buy ahead 90 days or sometimes even up to a year to plan for that future growth. And the problem with that is that you're paying for storage capacity that's sitting idle and waiting to be used. After applying RAID configurations, formatting, and setting up the file system, you may be up to a petabyte of raw storage that you're actually buying for. And the common problem with this is that you're provisioning based on anticipated needs and formatting rather than real-time usage. With AWS storage, that's different. Things are different. You only pay for the storage that you use, and the infrastructure scales elastically with your data needs. So RAID, overhead, formatting, losses, capacity planning, that's all dealt by AWS storage rather than if you were managing that on-premises. And when you use AWS native tools like compression and deduplication, your actual storage may be even less than you anticipated. But taking a step back, as you move workloads from on-premises to the cloud, cost optimization is not just about migration. It's really a journey and a continuous process. When you think about, initially it might be lift and shift, and there might be some cost savings, as we just talked about. But it's also about right-sizing your instances, using EC2 optimizations, storage optimization, using managed services like Amazon S3 or EFS, and to get down to a true AWS optimized cost, which are future-proofed because you're more efficient and you can elastically grow as your demands require. There's a lot to cover here, and we're not going to do that today. We're really just going to focus on the storage optimization part of it, as there's other sessions where you can learn more about these topics. All right, a real-world example. T-Mobile was on premises, and they had a number of new initiatives that caused scaling challenges and performance challenges that they were running into. They decided to move to EFS for the Elastic File Service, an AWS cloud-native offering. Their on-premises, as we talked about, required provisioning and managing that. And what they found is that when moving to EFS, they were actually able to reduce their storage costs by up to 70% because of removing some of the over-provisioning, but also using the cloud-native tools that EFS provides to further reduce costs. And one of the unique benefits that they also found was that before, because they had a plan for hardware and landing and everything like that, they were actually able to reduce their time to market with new initiatives because they didn't have to factor that in. All right, so once you're in the cloud or choosing which workload is for the right service, there's 4 different services that you can really choose from. And it's really the first decision point that you make for a particular workload. So let me introduce the services. First is Amazon EBS. It's high-performance block storage, and it's really designed for those, and ideal for those SAN workloads that you might be running on premises. It supports databases like SAP HANA or Oracle. Next is Amazon FSx. It's fully managed file storage for NAS workloads, and it offers similar like-for-like capabilities that you might find with NetApp for ONTAP, Windows File Server, OpenZFS, or even Lustre to meet for specific applications. It's really designed to be like for what you would run elsewhere and makes migration super simple. Next is Amazon EFS. It's a serverless elastic file storage that grows and shrinks automatically and is perfect for shared file access, like, for example, if you have user shares or content management. And last but not least is Amazon S3. It's object storage designed for scalability, durability, and has features like intelligent tiering to automatically tier data up and down based on access. It's the foundation for use cases like modern data lakes, backups, and even mobile apps. Each of these services are designed for different storage needs, and so picking the right one to ensure that you have the correct cost efficiency, scalability, and performance of your workloads is important. So throughout this presentation, we're going to go into each of these services, identifying what workloads are the right fit, and then once you're using that service, how you can further cost optimize to reduce storage costs. And to start, we're going to start with Amazon EBS, which is AWS's high-performance block storage. So why would you choose EBS? Oftentimes we have customers that have existing SAN workloads, and EBS works great. For example, typical EBS workloads are relational databases like MySQL, NoSQL databases like MongoDB, big data analytics like Hadoop, or enterprise applications like SAP HANA. So if you have one of these workloads, EBS is a great choice. It provides top-tier performance with up to 256,000 IOPS per volume and 420,000 IOPS per instance. And EBS can handle even the most performance-sensitive workloads, delivering consistent sub-millisecond latency. And to effectively manage your EBS storage and optimize costs, it's essential to select the right volume type. This is really the second decision you make after selecting EBS as for your workload. And EBS offers several volume types. On the left, you see GP2 and GP3. These are your general purpose volume types that are a good fit for a wide variety of workloads. Next, you have IO1 and IO2. And these volume types are really designed for those mission critical applications that require high IOPS and low latency. Third, and really we probably don't talk about this enough, but when it comes to cost optimizations, ST1 and SC1 are really providing a lower price point for HDD-backed workloads. So first is ST1, which is a throughput optimized HDD. So you might use this for data warehouses or log processing. And then you have SC1, which is designed for infrequently accessed or archival workloads for data that really you're thinking about archiving and it needs to be in a block format. So let's focus on the two most popular volume types, GP2 and GP3, as they are the most widely used for EBS. And let's explore the differences. First, for GP2 volumes, you get a baseline performance of 3,000 IOPS with the ability to burst higher for workloads that require that performance. However, an important consideration is performance is tied to the size of the volume, which may lead to over-provisioning if more performance is needed than the volume size. On the other hand, GP3 volumes solve this problem by decoupling performance from the size of the volume. GP3 gives 500 IOPS per volume with no burst mode needed, making it ideal for high-performance workloads that need to burst higher by decoupling the IOPS from the actual volume size. Moreover, GP3 is 20% cheaper at 8 cents per gigabyte month versus GP2, which is at 10 cents per gigabyte month. So Immediately, one of the first things that we would recommend is for customers to choose GP3 over GP2 because it's a clear way to reduce costs and boost flexibility. Another cost savings technique with EBS is using elastic volumes. Elastic volumes provide flexibility, allowing you to adapt your storage without affecting operations. With this feature, you can increase or decrease the volume size on demand. So for example, let's say your application suddenly requires more storage, and you can expand that volume in minutes using elastic volumes. Alternatively, if you need more or less IOPS, you can adjust IOPS dynamically to meet performance requirements, ensuring you're not overpaying for that unused capacity. Elastic volumes also allows you to actually switch the volume type. So you may start with GP3 because you have a high performance need, and then if that data cools, you can actually switch to, or your application needs less performance, you could switch to one of the HDD volume types, such as SC1. And so by using elastic volumes, you can stay agile and avoid that over-provisioning, which is one of those leading causes of unnecessary storage costs. Devo is a great example who was able to use both of these two techniques, using elastic volumes and migrating from GP2 to GP3 to save costs. First, as I mentioned, they migrated from GP2 to GP3, which saved them about 20% on their storage costs. And then they're using elastic volumes as their application needs change. What they do is they start with GP3, which is that SSD-backed volume type, and then periods of low demand, they switch to the SC1 volume type, which is HDD-backed. And this resulted in significant cost savings for them, and it all happened with zero downtime as they were changing volume types. You can also reduce costs when you're using EBS snapshots. Snapshots are incremental, point-in-time copies of your data, and they're an easy way to back up your volume. There's two types of snapshots. First is the standard snapshots, and these are ideal for those frequent backups or disaster recovery because you can store data very quickly. On the other side is snapshots archive, and these are more designed for long-term retention and infrequent access. However, they're 75% cheaper than standard snapshots. So if your data can be archived and you can handle restore periods of 24 to 72 hours, using Snapshots Archive is a clear way to save up to 70% on your snapshots costs. A real-world example of this was Johnson & Johnson, who saved over $1 million by migrating their snapshots that they had to have for compliance reasons into Snapshots Archive. All right, so let's wrap things up with Amazon EBS and some of these 3 best practices for cost optimization. First, migrate from GP2 to GP3. It's a clear win, and it allows you to save up to 20% on your storage costs. Second, use elastic volumes to modify the volume size, the type, or the performance, and decouple performance from the storage size. It ensures that you're only paying for what you need at a given time. Third, when you're using snapshots, consider using Snapshots Archive if you do have volumes that are no longer being accessed and will be better off in an archive tier. These strategies will help you optimize performance while minimizing storage costs with EBS. Switch gears for a second. All right, I'm back. We're going to switch gears for a second and talk about Amazon FSx, which is our fully managed file services for NAS workloads. Let me start with a bit of background about Amazon FSx. Organizations around the world have stored exabytes of data on network-attached storage, or NAS. And because file storage has been around for decades, there are mature NAS file system solutions that have grown up on premises. And a lot of individual file systems that organizations have deployed and managed throughout the years. But as organizations migrate from on-premises to the cloud to increase agility, accelerate innovation, or reduce costs, they often find they need a way to bring those file systems that their applications rely on. And this is what Amazon FSx enables. It has enabled thousands of customers to do so, to migrate to the cloud by providing fully managed NAS file systems on AWS. And we've built these like-for-like solutions for 4 popular file systems on premises. We've built FSX for Windows File Server for those Windows-based file systems, FSX for NetApp ONTAP for customers that rely on the NetApp ONTAP file system, FSX for Lustre and OpenZFS for those open source file systems that you may be running, especially for scale-out workloads. And in each case, because the FSX solutions have the same features and functionality as their equivalents on premises, customers can bring the file data they had on premises to AWS without needing to re-architect workloads, reinvent workflows and processes, recertify applications, or retrain users. And FSX also provides a broad set of cost optimization capabilities, with a few of them being listed on the screen. For example, there's data compression and deduplication, and this reduces the amount of storage used without sacrificing performance. Thin provision volumes and storage quotas to efficiently allocate space without avoiding that over-provisioning. Choice of storage types, including SSD and HDD options, and the ability to deploy in either single AZ or multi-AZ environments, depending on your availability needs. The automatic data tiering and dynamic scaling to support evolving application requirements. These features make it easy to adapt FSX for your application workloads for file systems that you're already running. All right, we just listed out a bunch of cost optimization features, but let's put that into practice with a deep dive on NetApp for ONTAP and how FSX enables for file workloads. First, FSX for ONTAP offers intelligent bidirectional data tiering. This means that the system automatically moves data between tiers based on usage patterns. There's an SSD storage for active, high-performance data with sub-millisecond latencies. And then there's a lower-cost capacity pool storage for infrequently accessed data, which automatically grows and shrinks to optimize costs. What we find, though, is actually customers only need about 20% of their data in that SSD tier. And 80% of that data should live in the capacity pool storage. And because FSX for NetApp ONTAP has bidirectional tiering, your storage feels like it's all in the SSD tier, but at the fraction of the cost. With auto tiering, you generally save about 2/3 off your storage costs by having less frequently accessed data in that capacity pool. In addition, ONTAP supports both data compression and deduplication, which enables you to save about another 2/3 off your storage costs. So what this means that in total for a typical data set, you actually save about 88% off SSD pricing and pay as little as 3 cents per gigabyte month. And at that price, you get a fully managed multi-AZ feature-rich file storage. Arcesium is a leading financial technology and professional services firm that was managing NetApp for ONTAP on premises and decided to move their infrastructure to the cloud for FSX for NetApp ONTAP. On premises, they were struggling with that same sort of story around over-provisioning, and they actually had some performance issues. When they moved to the cloud, they actually saw a 46% reduction in storage costs. Their database speed improved by 5x, and they saw an 80% reduction in the refresh costs because they're no longer needing to managing the provisioning of storage. Now, interestingly, within that FSX families of services, what we've actually seen is a lot of customers are actually choosing FSX for OpenZFS as a destination, not just for the data sets that were already in OpenZFS, but also for data sets that were stored on a variety of both other open source NAS file systems and the commercial NAS file systems that you'll see. And this makes sense for a few different reasons. First, FSX for OpenZFS has an extensive set of NAS capabilities. So customers that were using other solutions on premises typically find that they can do everything that they could do on premises in the cloud with OpenZFS. Second, it's purpose-built for high performance, which has become increasingly important as organizations build applications that both run faster and at greater scale. And third, because OpenZFS is open source, you get all the benefits of a fully managed and supported offering without the licensing costs. So what that means is that translates into over 30% better price performance relative to those commercially licensed options. And to help you save even more money, I'm also excited to announce that just launched a few days ago is a new storage class available with OpenZFS. It's called Amazon FSx for OpenZFS, and the storage class is FSx Intelligent Tiering. With this new storage class, FSx for OpenZFS is the first fully managed storage solution that combines the familiarity with NAS with storage that's fully elastic and intelligently tiered, because it's based off the Amazon S3 Intelligent Tiering storage class, which if you're not familiar with, Arushi is going to cover in much more detail in a few minutes. But as with Amazon S3 storage, it grows and shrinks on demand, so it's fully elastic. And it means you no longer have to manage that storage capacity, and you can accommodate those unpredictable and spiky workloads. It automatically optimizes costs by moving data between access tiers, from a frequent access tier all the way down to an archive access tier. And it's designed to deliver that optimal price performance for NAS data sets, enabling you to bring those large NAS data sets that always didn't need SSD storage to the cloud. And we're really excited to talk to customers about this new storage class and how that helps them optimize costs. So let's talk pricing. With FSx Intelligent Tiering, much like the Amazon S3 Intelligent Tiering storage class, there's a per gigabyte month charge for data, and it starts at the frequent access tier at 2.3 cents per gigabyte month. Then as data cools and tiers off, it gets all the way down to 4/10 of a penny at 4/10 of a penny per gigabyte month. Like the Amazon S3 Intelligent Tiering storage class, you pay a fee for monitoring and automation, and this really covers that data movement to go up and down between the tiers as it's accessed. And then also for the first time for NAS, you actually pay for read requests and write requests, which is different because previously you would have provision for a certain number of IOPS. So you're only paying when you access the data. So now FSx Intelligent Tiering, so wouldn't you use FSx Intelligent Tiering? Because now there's sort of two deployment types. First is the Intelligent Tiering storage class, and then the second is the original provisioned SSD offering. You should really think about FSx Intelligent Tiering as the right choice for most workloads, even for high performance workloads. You never run out of space, and you never have to worry about provisioning storage capacity. However, if you have certain workloads that require the lowest latencies or where access patterns can be random, you should consider using the provisioned SSD storage class. For example, if you have like a subnet in an EDA or simulation workload, and you really need that low latency and high performance, SSD is probably still the right choice. However, the default choice for most workloads, including performance-oriented workloads, should be the Intelligent Tiering storage class. All right, let's wrap up the FSx session and talk about the storage efficiency's best practices. First, use the native tools like data compression and deduplication to maximize that storage efficiency with FSx. Second, if you're using NetApp for ONTAP, use the data tiering, because by leveraging both the SSD tier and the capacity pool tier, you can save up to 88% combined with that data compression and deduplication. Finally, you should consider using FSx for OpenZFS for 30% better price performance for NAS workloads, because you don't have to pay those licensing costs. And you can save even more by using FSx Intelligent Tiering as your default choice. Now I'm going to hand it off to Arushi, who's going to talk about EFS and Amazon S3.
Okay, thank you, Matt, and hi, everyone. So with Matt, you've already learned about the cost optimization opportunities that you have with Amazon EBS as well as Amazon FSx. So now let's dive into Amazon EFS. Amazon EFS, or the Elastic File System Storage Service, is a cloud-native, fully elastic, and a serverless file storage service that's designed for modern application builders. So I'll talk about some key use cases of EFS, But it's first more important to understand some of the key features of Amazon EFS. So as you can see here, EFS is configuration free. So it's highly available, durable, and secure right out of the box. And then EFS is fully elastic. This is one of the most key features of EFS. So you do not have to provision any storage beforehand, and EFS automatically grows and shrinks as your data grows and shrinks. And then EFS is accessible from anywhere. That means be it your AWS compute, your serverless functions, containers, it can be accessed from anywhere. And finally, EFS is cost optimized. So you have a pay-as-you-go model, so you can make sure that you only pay for what you use and nothing extra. EFS also has certain cost optimizing tools that are available that I will talk about shortly. So now if you're thinking about the key use cases for EFS, one of the most important use cases is to host an elastic file system that can be shared across multiple Amazon EC2 compute instances. Now, this can help you simplify your DevOps by sharing files or sharing code. So basically, that makes the life of developers, engineers, scientists, ML engineers quite easy. Because we just learned that it is accessible from anywhere. You can also use EFS to persist your data, because we just learned that it is cost optimized. It also has certain storage classes that are optimized for archive data for long-term storage. And then you can also use EFS if you have applications that consistently create, modify, or delete file data. And I say that because we just learned that EFS is fully elastic. So you don't have to worry about over-provisioning any storage beforehand in case you run out, because EFS is automatically going to take care of that. So now let's dive into these storage classes that EFS offers. So one of the key decisions that you always take before you start using any cloud storage is to choose the right storage class. And I say that because each of these storage classes is custom designed for a specific workload to provide you the best price performance. So first, you can use EFS standard if you have workloads that frequently access your data, because this storage class offers you the highest performance, and it seamlessly integrates with your AWS compute containers and all serverless workloads. However, if you think that your data is going to be less frequently accessed, you do not actually have to pay for a frequently accessed storage. And you can simply use the EFS infrequent access storage class. However, it's also possible that you just have requirements where you need to store your data for a longer period of time, but you don't actually access it much. So for that, you should benefit from the EFS archive storage class, which is the storage class that provides the lowest cost across all the EFS portfolio and is designed for some of the archive data. Now, typically, you will have data that's going to start with frequent access. So you might want to start keeping it in your EFS standard class. Say you have a media processing application, and you're accessing your media files frequently. But over time, say when you have already done your processing, probably built a movie or something, after a couple of months, you might not have to access it frequently. And that's where you want to move it to infrequent access and then to EFS archive. But don't worry, you don't have to do it manually, because we have a cost optimizing tool that you can use, which is configuring EFS lifecycle policies. Now with EFS lifecycle policies, you can let EFS automatically do the job of moving your data across these storage classes. So within 30 days, it'll move to infrequent access, and then after 90 days, it moves to EFS archive. In fact, you can also create lifecycle policies to move your data back from these storage classes to EFS standard. It is accessed. Now, how that helps is that all your subsequent apps will again performance. Can you hear me? Yeah, sorry. All right, so this ensures that you're only paying for the storage class that aligns with your data's usage. Now, the next factor that you can optimize for after your storage class is your throughput mode. And EFS has you covered on that side. So first, if you have your application that has consistently high throughput requirements, then what you can do is benefit from the provision throughput mode. In this throughput mode, you can work out what is the throughput requirement of your application and provision that beforehand. So consistently throughout the job runtime, you're going to get a higher provision throughput. So this fits perfectly for data-intensive applications where you need like highest performance, because this throughput mode provides you high throughput to storage ratios. However, it's quite possible that you don't know your throughput requirements, or maybe your throughput requirements are changing over time. And in that case, you should benefit from the elastic throughput mode. In fact, this is the default throughput mode as of today. So it automatically adjusts your throughput mode as your data grows or shrinks, making it ideal for workloads with unpredictable performance requirements. Let me tell you a real-life example with the success story of Johnson & Johnson. Now, they were looking for a scalable solution to share and analyze hundreds of terabytes of data. So they wanted an elastic storage solution that could also have enhanced computing capabilities so that their scientists could actually perform analytics and, for genomics and drug discovery. So they used EFS and were able to get faster time to insights and were able to reduce their analysis time by 37%. That's already a win in terms of your compute costs. However, they also used EFS lifecycle management policies and transitioned their data between the standard storage class and infrequent access storage class, and were able to realize up to 35% cost savings. These are really impressive results. So if you have file data, I would really encourage you to take a look at these tools. So with that, let's wrap up the EFS section with the best practices that we just learned. The first step, as I mentioned, is always to choose the right storage class for your workload. You can benefit from the standard storage class if you have frequently accessed data, but you don't have to do that if you do not access your data frequently. So if you have rarely accessed data, benefit from a lower cost storage class, that is the EFS archive. Next, configure the lifecycle management policies, because it automatically lets EFS do the job of moving your data across storage classes and making sure that you save on your storage costs. And finally, choose an optimal throughput mode. You can benefit from the provision throughput mode if you really need the highest performance throughout. But if you do not need that, or if you have elastic requirements where you don't know your throughput requirement throughout the job runtime, you can always benefit from the elastic throughput mode. So by following these best practices, you can ensure that your storage costs are aligned with your performance requirements. And with that, let's move to the object storage of AWS. That's Amazon S3, or Amazon Simple Storage Service. You can use Amazon S3 to build your data lakes, or for backup and restores, or in fact, even to store data just to fuel your GenAI applications. And just like we did in EFS, the first step here for cost optimization is to select the right storage class. Because again, each storage class is purpose-built to provide you the best cost and performance for specific workloads. So let's start with the first storage class that you see on the left side of the screen, which is S3 Express One Zone. This is a high-performance storage class that we launched last year that gives you consistently single-digit millisecond latencies. Now, while it costs slightly higher to store your data in this storage class as compared to the other storage classes, I want you to pay attention to the fact that this might actually be the lowest cost storage solution for your workload if you're running high-performance workload. Now, say think about a scenario where you're running ML training jobs or your data analytics job. And for these customers, typically tend to use really expensive GPU instances. So in those cases, saving on your compute cost becomes the most crucial factor. Now imagine you're using S3 Express One Zone, and you're consistently getting single-digit millisecond latencies. And in that case, you will be able to reduce your compute time, which translates to a lot of savings in terms of overall AWS cost. Next, let's take a look at S3 Intelligent Tiering. Let me say one thing here, that if you're not using S3 Intelligent Tiering, it might be one of the best ways to save money on your storage cost. Just like Matt covered it in the FSX section, I'll also be talking about it, but just down a couple slides. But first, I'd like to talk about the S3 standard storage class, which is one of the most commonly used storage class in S3. So if you have frequently accessed data and your application can handle slightly more than single-digit millisecond latencies, you should consider using S3 standard. This is because it has no retrieval fees, no minimum retention period, and no minimum billable object sizes. Now, as you move towards the right, you will progressively move towards the colder storage classes. What that means is that progressively it costs lower to store your data in those storage classes, but it progressively costs higher to retrieve your data out of those storage classes. And it also takes longer to retrieve your data out of those storage classes. If you take a look at the names of the storage classes, whenever you see Glacier in the name, it's designed for a storage class, which is for archival data, or basically data that's rarely accessed. So in terms of performance, the Glacier Instant Retrieval Storage class has a similar millisecond performance similar to S3 standard. But the Glacier Flexible Retrieval and Deep Archive storage classes are asynchronous storage classes. What that basically means is that it's a two-step process to retrieve data out of them, so it can take from minutes to up to hours to get data out of these storage classes. So it's your decision to figure out if your application can handle that latency. Now, to choose the right storage class, you can take into consideration a couple of factors. First is the access frequency. So it's important to understand how frequently your application is going to access data out of that storage class, because you want to balance the lower cost of the colder storage classes versus the higher request and the retrieval fees of the storage classes. Second is the retention period. How long is your data going to stay in that storage class before it is, say, moved or deleted? And finally, it is the retrieval time. How long can your application wait when it tries to access the data out of that storage class? As an example, it costs 75% lower to store an object in Glacier Deep Archive as compared to storing it in Glacier Instant Retrieval. But if you remember, I just mentioned that Glacier Deep Archive can take minutes to hours to take your data out of that storage class. So it's on you to figure out whether your application can handle that latency. Now, you might be thinking this is a lot of information. What if I just don't know what my application's access patterns are? Maybe they are just unpredictable, unknown, or changing. In fact, that is the scenario with most of the workloads. And that is where S3 intelligent tiering is your answer. S3 intelligent tiering consists of various access tiers, including many hot and cold access tiers, and it automatically moves your data from the hot tiers towards the cold tiers based on your object's last access date. The transition occurs at an object level, so object starts in the frequent access tier. If not accessed for 30 days, it moves to infrequent access tier, and in 60 days, it moves to archive instant access tiers. There are two additional tiers which are optional, and you can opt into them. And you have flexibility in choosing how long intelligent tiering will wait before transitioning data into those access tiers. In terms of performance, the first three access tiers provide you the similar millisecond performance like S3 standard, but archive access tier and deep archive access tier have similar performance as Glacier Flexible Retrieval and Glacier Deep Archive. Now, in terms of cost, there is no transition charge as your data moves across these tiers, but there is a small monitoring fee that's unique to intelligent tiering. But remember that there is no monitoring fee for objects smaller than 128 kilobytes because those objects never tier and always stay in the frequent access tier. So it's important to use intelligent tiering if you have a lot of larger objects as well. An interesting stat that we have learned that since the launch of intelligent tiering in 2018, our customers have actually saved more than $4 billion. And this is by just letting S3 intelligent tiering automatically manage their storage infrastructure. These are very encouraging results as we learn that our customers take these savings back into their businesses instead of having to manually manage their own S3 storage architecture. Now, we already talked about the unknown or the changing access pattern. But what if you already actually understand your access pattern? In that case, you can probably make more explicit and better choices to move your data across storage classes to save even more. And for that, we have a cost optimizing tool that you can use, which is lifecycle policies. This is similar to what we talked about in EFS as well. The lifecycle policies are rules that S3 applies to groups of data, and there are two types of actions there. First is a transition action that moves your data from a hot storage class to a cold storage class, and the other is the expiration action, which basically deletes the data. Now, lifecycle policies are triggered based on the age of the object. Now, also remember that with lifecycle policies, you are actually paying for the transition. So the transition cost is dependent on the storage class that it's transitioning to. Colder the storage class, more is the transitioning charge. But there's an important caveat here. The transition charge is only per object, and it does not depend on the size of the object. So a pro tip here, if you're moving your data with lifecycle policies, you can always club your data, create larger objects, so that it costs you lesser to move your data to a colder storage class. With lifecycle policies, you can also use filters. For example, on prefixes, object tags, object size. You can use it to delete, say, incomplete multi-part uploads to save on your data, save on storage cost. I can also give an example here. So for example, we just mentioned the transition charge is only based on number of objects and not object size. So what you can do is add a lifecycle filter and only transition objects that are greater than a specific size. In that case, you're getting the best benefit. Here's a real-world example. So one of our customers, Illumina, performs groundbreaking advancements in life science and research and genomics. And after only 3 months of using S3 intelligent tiering and lifecycle policies, they were able to achieve a 60% reduction in their storage costs. So I would also encourage each one of you to try it out. Now I talked about storage classes and like how to select them based on your workload types. But how do you know the impact of what you're already doing? What's the impact of these decisions? In fact, take a step back. How do you even know today that you need to change something? Because you cannot change what you cannot see. So you need to gather insights from your data. And that is where S3 Storage Lens comes into picture. S3 Storage Lens is the first stop that we recommend our customers in order to gain an organization-wide visibility into their S3 storage footprint. In fact, it doesn't just provide visibility into cost optimization opportunities, it also provides data protection, access control, and performance optimization opportunities. In fact, I would say everyone should use S3 Storage Lens. And why is that so? Because there are 28 free metrics for you to use and gather visibility from your data. So you can easily figure out if you're already using a lower cost, colder storage class. And if not, you can probably actually go and start using it. Now there are 35 advanced metrics also that you can upgrade to and use them, and they obviously provide better capabilities. For example, more history for a better trend analysis. Storage Lens also provides you the ability to drill down and view metrics at different aggregated layers. For example, you can always start at an organizational layer and then drill down to an account layer, the region level, and all the way up to a prefix level in order to make decisions at the level that provide you the most benefit. You can also make use of S3 Storage Lens groups in order to customize your aggregation level for your metrics. So for example, you could choose to customize based on object tags, object size, file extensions, or even prefixes. So if you customize your metrics and aggregate them based on file extensions, you can try to figure out what type of data exists in your, say, a bucket. So for example, if you figure out that there are a lot of log files within your bucket, what you can do is, it provides you a strong insight, and what you can do is set a lifecycle policy and move your data away to a cold storage class if you know that you're not actually accessing your log files after, say, a couple of months. I actually also want to give you a real-world example here. So Upstocks is a leading Indian discount broker, and they provide financial education. Here we go. So Upstocks is a leading Indian discount broker, and they provide a digital platform for investment to more than 11 million customers. So Upstocks use S3 Storage Lens advanced metrics along with a few other AWS services in order to try to reduce the storage costs. And they were able to realize a saving of more than $1 million annually. So the major contributor here was to figure out where they had infrequently accessed data. And then they moved them to Glacier Instant Retrieval Storage class using lifecycle policies. And with that, we come to an end of the section of Amazon S3. So let's summarize some of the best practices that we just discussed. First step, as always, choose the right storage class from the Amazon S3 portfolio. This will depend upon your data access frequency, your object sizes, your data retention requirements. And then after that, if your workload's access patterns are unknown, you should benefit from S3 intelligent tiering by allowing it to automatically manage your storage architecture and moving your data to colder access tiers. It is actually the right choice for most workloads and the best choice for unknown access patterns. But if you do understand your workload's access patterns, leverage the lifecycle policies to transition your data to colder storage classes, or to expire your data and save on cost. And finally, use S3 Storage Lens to get more visibility into your bucket policies, your access patterns, and your object sizes. And all of this can help you make better data-driven decisions and finally save on your storage cost. And on this note, we're coming towards an end of this session. And I hope you've learned how you can narrow down your choices and have gained some practical tips that you can start using today to optimize your storage costs with AWS. You can scan this QR code to get started with the AWS storage training. Now, please fill out the survey in the mobile app. We do read all of your feedback and then use it to improve our sessions going forward. Thank you so much.